Hi, good evening, everyone. This is Shefali Singla. In this session, we will be talking about decomposition of a relation. कल हम लोगों ने start किया था, so we discussed that there are two properties to be true if a decomposition is correct. So one is lossless decomposition and other one is dependency preserving. तो lossless और lossy कैसे check करते हैं वो कल वाले session में हम लोगों ने discuss किया था. Using the attribute closure, we were finding the key. And in today's session, we will be talking about the dependency preservation. Very good evening, Nitika. आज वाले सेशन में हम लोग बात करेंगे dependency preserving की. So as discussed yesterday, so when you are when you are trying to join the sub relations, then on joining them, you may get some extra rows. But जब हम dependencies की बात करते हैं तो sometimes what happens is जो भी relation R में dependencies given है, some of the dependencies may get lost. So let's consider there is the relation R, original relation R. This relation R is decomposed into the sub-relations R1, R2, R3 and so on Rn. So relation R is decomposed into the sub-relations R1, R2, R3 and Rn. Now for the relation R, there is some functional dependency set given to you. For example, functional dependency set is F. इस relation R के लिए functional dependency set आपको F दिया गया है. तो अगर relations decompose हुए हैं तो definitely कुछ dependencies होंगी जो sub relation R1 में preserve हो रही हैं, कुछ R2 में हो रही हैं, कुछ R3 में हो रही हैं. So I'm calling this as F1, F2, F3 and so on up to Fn respectively. But now here, if we talk about the all the dependencies, अगर आप सबको join करते हो, then it might be producing less number of dependencies than the original one. That means अगर मैं यहाँ पे सारी functional dependencies का union लेती हूँ, F1 union F2 union F3, सारी functional dependencies अगर हम consider करते हैं, then it may be subset. प्रॉपर सबसेट मीन्स कुछ डिपेंडेंसीज कम हुई है, लॉस्ट हुई है, और इट कैन बी इक्वल. कभी भी ग्रेटर वाला केस नहीं आएगा. कभी भी अगर आप सारी फंक्शनल डिपेंडेंसी सेट का यूनियन लेते हो, इट विल नेवर प्रोड्यूस द एक्स्ट्रा डिपेंडेंसी. सो दिस इज पॉइंट नंबर 1. नाउ if it is returning the same number of dependencies, सारी की सारी dependencies sub relations में भी preserve हो रही हैं, in that case we are saying that the decomposition is dependency preserving. अगर एक भी dependency lost होगी, that means it is not preserving all the dependencies. नाम से समझ में आ रहा है, nothing complex. So a relation R is decomposed into the sub relations R1, R2, R3 and so on up to Rn. So R is dependency preserving. R को dependency preserving कब बोलेंगे? With respect to the set F. अभी हमने example consider किया. So if you are taking the closure of all the functional dependency set, then it is producing all the set of the original functional dependency. Let us assume अगर relation R is decomposed, पहले हम छोटे example से start कर रहे हैं. So relation R is decomposed into R1 and R2. तो R की functional dependencies को हमने F बोला है. This is F1, this is F2. Now F1 union F2 यानी कि functional dependency set F और जो functional dependency set 2 है, दोनों को मिलाकर original relation R की सारी functional dependencies आ रही हैं, then we'll say that decomposition is dependency preserving. If it is generating the proper subset, अगर subset आ रहा है, then it is not dependency preserving. और अगर superset आ रहा है, superset वाला केस कभी भी possible नहीं हो सकता, because it cannot produce any new dependency from its own side. Is this point clear? So this is about the introduction to dependency preserving. अब question के ऊपर apply करके देखते हैं कि check कैसे करना है. So when we'll be talking about the dependency preservation, तो हमारे पास दो तरीके होते हैं check करवाने के. One is known as mapping and दूसरा तरीका होता है कि आप non-trivial functional dependencies find करते हो. So there are two methods to check whether the decomposition is dependency preserving or not. First one is आप functional dependencies को map करवा दीजिए. डायरेक्टली जो भी फंक्शनल डिपेंडेंसीज मैप हो रही हैं विल टेक दैट, और जो नहीं मैप हो रही हैं उनके लिए आप नॉन ट्रिवियल फंक्शनल डिपेंडेंसीज फाइंड कर लीजिए. Find out the set of non-trivial functional dependencies and then check whether the dependency is preserved or not. Now question arises is, what is this non-trivial functional dependency? Dependency. What is non-trivial functional dependency? Non-trivial functional dependency होती है जब कोई भी dependency कुछ attributes को determine करती है which are not but obvious. But obvious means left hand side और right hand side पे कोई common attribute नहीं है. For example, A is determining B. और अगर मैं स्टूडेंट टेबल से रिलेटेड बात करूं, स्टूडेंट आईडी इज डिटरमाइनिंग स्टूडेंट नेम. सो दिस इज एन एग्जांपल ऑफ स्टूडेंट नेम और marks, something like this. So this is known as non-trivial functional dependency. ये क्लियर हुआ what is trivial and what is non-trivial dependency? So non-trivial dependency means अब यहाँ पे left hand side पे there is nothing common. So a dependency is said to be non-trivial अगर x determine कर रहा है y को and there is no attribute common. अगर आपको common find करना है we find out the intersection. So x intersection y is equal to 5. यानी कि left और right side पे कोई भी common attribute नहीं है. Then in such a case we say that the functional dependency is non-trivial. Trivial क्या होगी? When a attribute is determining itself. For example, student ID is determining student ID. Sorry guys. Student ID is determining student ID. So this is an example of trivial functional dependency. Make sense? So when we'll be looking for the dependency preservation, we will be looking for the mapping method and the non-trivial functional dependency. Mapping is very very simple. जो भी dependency के attributes हैं, functional dependency में अगर हम first functional dependency की बात करते हैं, we are getting two attributes, that is A and B. So अगर ये दोनों attributes किसी भी relation का part है, तो that means that relation will be preserving that dependency. What do I mean by this point? So let's write here the decompositions. Relation R having four attributes A, B, C, D. This is decomposed into 1 and 2 sub-relations. Okay, so this is R1 having the attributes A, B, C. R2 having the attributes C and D. Now, first of all, we'll try with the mapping method. Method 1, mapping. क्या मैप करवाना है? फंक्शनल डिपेंडेंसीज. तो गो टू द फंक्शनल डिपेंडेंसी सेट. इसमें पहली डिपेंडेंसी आ रही है A determines B. In this functional dependency there are two attributes used, A and B. अब ये जो आपके पास decomposed relations है, इनमें देखो AB कहाँ पे आ रहा है? Relation R1 में we are getting AB. That means first functional dependency is preserved by this relation. Similarly, B determines C. B and C, two attributes are used. Both the attributes are a part of R1. So B determines C is also mapped here. C determines D. Two attributes are being used. So C determines D means it is preserved by relation R2. मैंने ये purposefully बहुत simple example लिए so that you can understand the difference between the mapping method and finding the non-trivial functional dependencies. So mapping is, I guess, very simple. Just you have to check for the attributes and you can decide that that particular functional dependency will be preserved by which subrelation. First method clear? Now let's check with non-trivial functional dependencies. This is method 1. आप ऐसा भी कर सकते हो, जो भी functional dependencies method 1 से आ रही हैं, मैप हो रही हैं डायरेक्टली, उनको करवा दीजिए. जो डायरेक्टली मैप नहीं हो रही है, सिर्फ उनके लिए non-trivial functional dependencies find कर लो. So now here let's consider method 2. Method 2 is using non-trivial. We'll be find non-trivial functional dependencies. Non-trivial functional dependencies. Let's calculate for relation R1 first. रिलेशन R1 के लिए फर्स्ट एग्जांपल है नॉन ट्रिवियल फंक्शनल डिपेंडेंसीज क्लियर हो इसलिए मैं सारी फाइंड कर रही हूँ बट क्वेश्चन में वी नीड नॉट टू फाइंड आउट ऑल द नॉन ट्रिवियल फंक्शनल डिपेंडेंसीज हम सिर्फ उन एट्रीब्यूट का क्लोजर फाइंड करके नॉन ट्रिवियल फंक्शनल डिपेंडेंसीज फाइंड करेंगे जहां से फंक्शनल डिपेंडेंसी स्टार्ट हो रही है but for this example I'm finding all the non trivial functional dependencies. First of all यहाँ पे आपके पास attributes आ रहे हैं A B C. So I'll be finding out A closer. What is A closer? Functional dependency set को refer कीजिए. A closer closer आपको find करना आता है right? So A closer will be determining itself. A is determining B. B is determining C. B C को determine कर रहे हैं. C D को determine कर रहे हैं. So A closer is A B C D. बट रिलेशन R1 में आपके पास सिर्फ और सिर्फ तीन एट्रीब्यूट्स आ रहे हैं A, B एंड C. सो वी विल नॉट बी कंसिडरिंग दिस. अब इससे डिपेंडेंसीज क्या बन सकते हैं? A determines A. This is trivial functional dependency. A determines B. This is non-trivial functional dependency. A determines C. This is also non-trivial functional dependency. Similarly, you can find out B closer. B closer. B closer will be B, C, D. Similarly, C closer will be C, D. Closer find करना आता है सबको. Now, find out the non-trivial functional dependency. Non-trivial means there should not be any common attribute between the left-hand side and the right side of the dependency. So B खुद को determine कर रहा है, common है. D is not a part of the subrelation R1, so I am discarding this attribute. So from here, we are just getting one non-trivial functional dependency. It is B determines C. C से start होके कोई non-trivial functional dependency बन रही है? No. So that means sub relation R1 के लिए आपके पास तीन non-trivial functional dependencies आई. Similarly, we can find for R2 C closer is CD and D closer is D. So for this relation, we are just getting one non-trivial functional dependency, that is C determines D. आपने non-trivial functional dependencies लिख ली. Now check what all dependencies are required. A determines B, this is preserved in R1. B determines C, this is also preserved in R1. ये भी R1 में आ रही है. C determines D, this is preserved in R2. So this is known as the non-trivial using non-trivial functional dependencies, and first one is mapping method. R1, this is also preserved by R1, this is preserved by R2. Since all the functional dependencies are preserved, सारी की सारी functional dependencies map हो रही है, so we'll say that given decomposition is dependency preserving. Given decomposition is dependency preserving. Make sense? So is this clear? So I hope that by this time now you guys are comfortable with what is dependency preserving में क्या conditions आ सकती हैं and किस तरीके से आप check कर सकते हो कि relation में dependency preserve हो रही है या नहीं हो रही है. Is this clear? If it is clear, after this we just have to consider a few more questions so that हम practice कर पाए. Okay, next example थोड़ा सा उससे tricky है, not much. So relation R having the attributes A, B, C, D, this is decomposed into three subrelations R1, R2 and R3. So this is decomposed into three subrelations, R1, R2 and R3. Attributes of R1 are A and B, R2, B and C, R3, C and D. So let us try mapping the functional dependencies. First dependency will be preserved where? First functional dependency directly mapping से check कर लो, कोई दिक्कत नहीं है. So first functional dependency A determines B. This will be preserved by which relation? A and B, two attributes are coming up. So that is present in R1. So A determines B will be preserved here. B determines C. This will be preserved. R1, this is preserved in B determines C. B and C कहाँ पे आ रहे? I'm so sorry. B and C कहाँ पे आ रहे? It is a part of relation R2. So B and C is mapped by R2. So this dependency is preserved by R2. Then C determines D. This is directly mapped by R3. C determines D. Now, fourth one, D determines A. Where are we getting D determine A? D is a attribute of relation R3. R3 में D आ रहा है और A R1 में आ रहा है, तो directly map नहीं हो रहा है. So, if directly mapping is not taking place, not directly mapped, तो हमें indirectly check करना पड़ेगा. Indirectly means we'll find out the non-trivial functional dependencies. कहाँ से start करना है? We need to go from D. So I need to find out D closer. D किस relation का part है? It's a part of R3. So I'll find out D closer. What is D closer? Go to the functional dependency set A, B, C, D. D is determining A. A is determining B. B is determining C. So what non-trivial functional dependency is coming up? इस रिलेशन में आपके पास सिर्फ और सिर्फ C और D है, तो A और B को डिस्कार्ड कर देंगे. एक ही नॉन ट्रिवियल फंक्शनल डिपेंडेंसी आ रही है, दैट इज D determines C. अब C से A तक पहुंचने का कोई तरीका है? लेट अस फाइंड आउट. लेट्स ट्राई फाइंडिंग आउट C क्लोजर. कहां पे फाइंड करेंगे? इन R2, क्योंकि C is the attribute of, you can find here in R3 as well, and C closer here. C closer is CD. D is determining A, A is determining B. C, D, A, B. जो attributes उस particular subrelation का part है, just keep them and discard others. So these two attributes are discarded. Here, these two attributes are discarded. एक non-trivial functional dependency और आ रही है, that is C determines D. Here we are getting C determines B. Try finding out B closer. B closer. B closer is B, C, D, A. B closer आप इस सब रिलेशन में भी फाइंड कर सकते हो, because B is a part of sub relation R1. So this is B closer. B, C, D, A. Just keep the required elements. So A and B are a part of this sub relation. B and C are the part of this sub relation. So one dependency is coming up, that is B determines C. Here we are getting B determines A. Okay. अब हमें डिपेंडेंसी चाहिए थी D determines A, बट आपके पास नॉन ट्रिवियल सेट में क्या आ रहा है? D determines C. D determines C, then we are getting one dependency, that is C determines B, and there is one dependency, this is B determines A. B determines A. So using transitive property, can I say that D determines A? Like A D C को determine कर रहे हैं, C B को determine कर रहे हैं, B A को determine कर रहे हैं. So transitively हम ये बोल सकते हैं D is determining A, and these dependencies are preserved. How? This is preserved in R3. D determines C आ रहा है. I'm picking up this one. Then C is determining B. यहाँ से यहाँ पे आया. Then B determines A. So indirectly this dependency is also preserved. R2 and this is R1. तो अब इस केस में आपके पास डी determines ए के लिए मैपिंग मेथड ने काम नहीं किया, हमें क्या करवाना पड़ा, वी नीड टू फाइंड आउट द नॉन ट्रिवियल फंक्शनल डिपेंडेंसी. So this is how you can proceed with the question. So since all the four functional dependencies are preserved by the sub relations, so we can say that given decomposition is dependency preserving, क्योंकि सारी dependencies preserve हुई हैं. So given decomposition is dependency preserving. So I hope that this is clear to everyone how to proceed with dependency preserving. कहाँ पे आप मैपिंग मेथड यूज करोगे, कहाँ पे आपको नॉन ट्रिवियल फंक्शनल डिपेंडेंसीज काउंट करनी है. सो यू नीड नॉट टू कैलकुलेट ऑल द फंक्शनल डिपेंडेंसीज. You can see here anyhow we are getting B determines C determines D, and here you'll be getting A determines B as well, because A closure is A, B, C, D. So we'll be discarding this. From here we are getting the non-trivial functional dependency, that is A determines B. ऑल्दो हमें ये सब फाइंड करने की जरूरत नहीं थी. आपको पता है डी ने सी को डिटरमाइन किया, सी से जो भी नॉन ट्रिवियल फंक्शनल डिपेंडेंसीज आएंगी जस्ट कैलकुलेट दैट. जो भी फंक्शनल डिपेंडेंसी आई उस एट्रीब्यूट से नेक्स्ट नॉन ट्रिवियल फंक्शनल डिपेंडेंसी, दिस वे यू मे गेट द रिक्वायर्ड डिपेंडेंसी. क्लियर? If it is clear, then let's take one or two more questions for the practice. Check the following decomposition is preserving the dependency or not. Relation R is given to you, which is decomposed into three subrelations R1, R2, and R3. So relation R having the attributes A, B, C, D, E, F, and this is decomposed into subrelations R1 having attributes A, B, R2 having attributes C, D, E, R3 having attributes E, F. R1, R2, R3. Now we need to find out whether all the dependencies are preserved by the decomposed subrelations or not. AB determines CD. AB is a part of R1, CD is a part of R2. तो दोनों same, सारे attributes same relation में नहीं आ रहे, तो here we need to check it with non-trivial functional dependency. C determines D. This will be preserved by which subrelation? C and D are a part of which subrelation? R2. That means C determines D is preserved here. D determines E. D and E, both the attributes are a part of R2, so this is also preserved here. D determines E. E determines F. E and F, both the attributes are a part of R3, so this dependency will be preserved by R3. सिर्फ प्रॉब्लम किस में आ रही है? A, B determines CD. For this, we need to find out the attribute closure. What will be the starting point? Since the functional dependency is starting from AB, so we'll find out AB closure. कहाँ पे find करेंगे? जहाँ पे भी ये दोनों attributes आ रहे हैं, it is a part of relation R1. So when I'll be finding out AB closure here, although answer हमें clearly दिख रहा है, but still AB closure is AB. AB is determining CD. C is determining D, D is determining E, E is determining F. But in the subrelation R1, we are just having two attributes, so we will be discarding all these four attributes. अब AB closure is determining AB, यहाँ से कोई non-trivial functional dependency आ रही है, we are not getting no non-trivial functional dependency. No non-trivial functional dependency is possible for this case. Functional dependency. So that means ये वाली dependency A, B determines CD is not preserved. This dependency is not preserved यानी कि एक dependency है which is lost. So we will say that overall this decomposition is not dependency preserving. So we got the answer. Given decomposition is not dependency preserving. Clear? Are you all comfortable? If yes, then let's check for one more subrelation. I guess, okay, this is the different one. So in the original relation R, we are given with 6 attributes. कल मैंने same relation लिया था, same functional dependency set लिया था, and we checked for lossy और lossless decomposition. अब हमें check करना है dependency preservation के लिए. Question कैसे आएगा? You might be given with some relation which is decomposed into sub-relations, and the functional dependency set will be given to you. And they may ask that which of the following is correct. Given decomposition is dependency preserving and lossless. Dependency preserving but not lossless. Not dependency preserving, lossless, not dependency preserving, not lossless. Something like this. So just try with this one. Relation R having 6 attributes A, B, C, D, E and G. This is decomposed into 3 subrelations R1, R2 and R3. For R1 attributes are A, B, C. For R2 attributes are A, C, D, E. For R3 attributes are A, D, G. So what is the first step? Go for the direct mapping. Because अगर सबके लिए आप नॉन ट्रिवियल फंक्शनल डिपेंडेंसीज फाइंड करोगे कर सकते हो कोई प्रॉब्लम नहीं है बट इट विल बी अ टाइम कंज्यूमिंग प्रोसेस सो डोंट गो फॉर इट सो ए बी डिटरमाइन सी ये सारे एट्रीब्यूट्स किस में आ रहे हैं R1 में ए बी सी सो ए बी डिटरमाइन सी इज प्रिजर्व्ड हियर नेक्स्ट इज दिस इज प्रिजर्व्ड इन R1 AC determines B, ABC तीन attributes आ गए ये किसके attributes है R1 के so AC determines B this is also preserved by R1 AD determines E AD and E AD and E so this is preserved by R2 AD determines E B determines D B is only present in R1 D is present in R2 or R3 यानी कि ये एक सब रिलेशन में नहीं आ रहा we need to check it with the non-trivial functional dependency. BC determines A, B, C and A all are present in relation R1. So this dependency is preserved by R1. E determines G, E and G both are present in, no, E is present in R2 and G is present in R3. So we need to check it with the non-trivial functional dependency. अब check करेंगे. First of all, let's try with B determines D. B is a part of relation R1. Let's find out B closer. Let's find out B closer here. B is determining D. That's it. That's it. So here in this subrelation D is not a part. तो B से start होके आपके पास कोई भी non-trivial functional dependency नहीं आ रही किसी और subrelation में possible नहीं है because attribute B is only a part of the subrelation R1. That means this dependency is not preserved. Anyhow अगर एक भी dependency preserve नहीं हुई answer is not dependency preserving. But let's check for whether E determines G or not. So I'll find out E closer. E is determining itself. E किसी और को determine कर रहे E is determining G. In this subrelation, we just have E, so this is not possible. So no non-trivial functional dependency is coming up. कोई भी non-trivial functional dependency नहीं आ रही जो E से start हो. No non-trivial functional dependency. Similarly, for this case, no non-trivial functional dependency. इसका मतलब E determines G is also not preserved. Non-trivial functional dependency. So clearly, what is the answer? Decomposition is not dependency preserving. Yes? Is there any doubt, any confusion? All good? Comfortable? All good? All set? So ये concept था हमारे पास functional dependency decomposition is dependency preserving or not. So we have covered both the properties of decomposition, that is lossless and dependency preserving. तो कोई भी decomposition correct होती है when it is lossless. That means there is no loss of data and all the dependencies are preserved. That is dependency preserving. Then we can say that the decomposition is correct. Okay. So we'll end our discussion here. If there is no doubt, then we'll end our discussion. Okay, let us try this question. इस तरीके का question आ सकता है. You are given with the relation R and here you are given with the functional dependencies. This is decomposed into the sub-relations. आपको बताना है क्या ये lossless and dependency preserving है. So this way 4 options will be given to you. The given decomposition is lossless join and is dependency preserving. Lossless है but dependency preserving नहीं है. Lossless नहीं है but dependency preserving है. ना ही lossless है और ना ही dependency preserving है. So just quickly find it out. Relation R A B C D. This is decomposed into sub relations. ये आज और कल वाले सेशन की समरी होगी. R1 में आपके पास दो एट्रीब्यूट्स आ रहे हैं A B. R2 में आपके पास दो एट्रीब्यूट्स आ रहे हैं B and C. R3 में आपके पास दो एट्रीब्यूट्स आ रहे हैं that is B and D. First of all, let's see if this decomposition is lossless. Lossless के लिए कैसे चेक करते हैं? We need to find out the union of all the subrelations. R1 union R2 union R3. R1 में कौन से एट्रीब्यूट्स आ रहे हैं? A and B. R2 के एट्रीब्यूट्स हैं B and C. R3 के एट्रीब्यूट्स हैं B and D. So 4 attributes are coming up. This is determining all the attributes of the relation R. So first condition is true. उसके बाद हमें कोई भी दो relations को लेना है. We need to try to join them. So let's find out R1 intersection R2. Is there any common attribute? Yes, B is the common attribute. So we'll find out B closer. ऐसे find किया था. B closer में क्या आएगा? B is determining B. B is determining C. C determines D. Anyhow, B closer is determining all the attributes of the relation R2. तो इसका मतलब R1 और R2 को आप join कर सकते हो because B is the key for the relation R2. So here we'll get R12 attributes will be A, B, C and R3 with the attributes B, D. Again, we'll find out the common attribute. Common attribute is R12 intersection R3, that is B. So we'll find out B closer. Already हम B closer find कर चुके. B closer is determining B, C, D. B and D, both the attributes of R3 are present. यानी कि B is a key for the subrelation R3. So we can join them. Since at the end we are getting only one relation, आपके पास single relation बचा है, इसका मतलब decomposition is lossless. This is lossless. Oops. This decomposition is lossless. तो ऑप्शन सी और डी में क्या बोल रहे हैं? इट डज नॉट गिव लॉसलेस जॉइंट डिकम्पोजिशन, इट डज नॉट गिव लॉसलेस जॉइंट डिकम्पोजिशन. दैट मीन्स ऑप्शन सी एंड डी कैन नॉट बी द आंसर. आंसर क्या होगा? ए और बी में से दोनों में लॉसलेस आ रहे. नाउ नीड टू चेक फॉर डिपेंडेंसी प्रिजर्विंग. So first of all, we'll go for the direct mapping. A determines B, this is preserved by R1. B determines C, this is preserved by R2. B determines D determines B, this is preserved by R3. C determines D, ये अलग अलग relations में आ रहा है, तो आपको non trivial functional dependencies find करनी पड़ेंगी. So out of 4 dependencies, 3 dependencies are directly mapped. D determines B. Now, in order to find out whether C determines D is preserved or not, we need to find out C closure. कहाँ पे find करेंगे? In the sub relation R2. C closure. C is determining D. D is determining B. So here D is not a part of this relation. So यहाँ पे आपके पास एक non-trivial functional dependency आ गई. That is C determines B. But we want C determines D. So we'll check for B closer. कहाँ पे check करेंगे? जहाँ पे B और D आने की possibility है. So let me find out B closer. B closer is B. B is determining C. C is determining D. We cannot take this one. B is determining D. This is non-trivial functional dependency. So this means that C determines B exist कर रहे. C determines B and B determines D, ये भी आ रहा है. तो इसका मतलब हम ये बोल सकते हैं कि transitively C is determining D. So this dependency is also preserved. This dependency is preserved by R2. This is a non-trivial functional dependency of R3. So this is dependency preserving. So given decomposition is lossless as well as this is dependency preserving. So correct answer for this question is option A. So these type of questions you can expect in the exam. I hope that you all are comfortable with all the conditions and the properties. So this is all about this session. If you want to learn more about DBMS or similar type of concepts in more detail, then you can join our live batch, that is Super Coaching batch. In the live batch, you will be getting the live classes for paper 1 as well as paper 2. Paper 1 की 6 days a week class होती है, that is at 12:30 in the noon, 12:30 noon from Monday to Saturday. Only Sunday is off. And for paper 2, daily we are having 2 sessions, one in the morning and other one in the evening. Morning and evening. For the morning session, timing is 7:30 to 9:30. And for evening, it's 8 p.m. to 10 p.m. For paper 2 or technical paper, there is no off on weekends. So in the evening, we are having off on Monday and Tuesday. And for morning sessions, only Thursday is off. Apart from this, there is a YouTube session. From next week, obviously, we'll be starting with concepts through questions because people were like, okay, we want to cover the questions first. So I'll be taking the sessions on concepts through questions. So particularly हम subject by subject questions उठाएंगे and then we'll be solving those questions और जो भी उस question में concept आएगा, I'll be discussing that concept. Okay, so I'm going to start a series that is concept through questions in the evening session. So if you want to join, you can. And definitely if you're liking the video, don't forget to like the video and subscribe the channel. To get to know more about the super coaching batch, So link is given in the description box. आप link को follow कीजिए and you'll get the details. Apart from that, if you want to get the notifications, click on the bell icon, and also my Telegram group is there. So just follow that group. Link obviously वो भी आपको description box में मिलेगा. So just go through the description box. Whatever information you guys might be needing, so it is there in the description box. Okay. So thank you so much, guys, for joining the session. I'll see you on Wednesday. Monday and Tuesday evening में off होते हैं, so I'll see you on Wednesday now. Till then, take care. Bye bye.